Okay, now we're going to calculate the shear strength of our beam. And the very first thing is we have to calculate the shear strength, the actual shear strength of the beam that we selected. And that beam that we selected is that W12 by 14 beam. So the formula that we use for this is, and you should take and write down this stuff here. Make sure you get this at the top of your page so you know what all these little letters are meaning. But the formula for this is our shear nominal is going to be equal to the shear actual times a safety factor. Now, the shear actual here, and that comes from our chart here, from our shear diagram, is 9,000 pounds. So Vn is going to be equal to 9,000 pounds, and that's going to be times the shear safety factor, which is a little less than the other one, and that is 1.5. So I'm going to take my calculator and I'm going to put in 9,000 times 1.5, and that equals 13,500 pounds. So 13,500 lb. So that is our shear for the actual beam that we are working with. Now we need to do the shear for the beam. This is what it has to do. It's not for the beam itself, excuse me. This is what we have to have it be greater than, a number greater than the beam does. So we're going to start by doing the calculation. So Vn, and this is going to be for the W12 by 14 beam. So I always write the size of the beam right there. And the formula for this is going to be equal to 0.6 times the yield point of steel times the area of the web. And here is where we're going to get into doing a little bit of stuff with the chart. So let's start by just writing out this formula. So Vn for W12 by 14 equals 0.6 times the yield point of steel, which is 50,000, and that should be pounds per inch squared, times this area of the web. Now what we do is, I'm going to just draw this up here so that we can get a good idea. 2, 3, 4, 5, and down 1 into, down 1 into. I'm just going to sketch out a I-beam here so that we can see what it looks like. Not doing a terribly great job, but it'll suffice. So what we need to do is we need to know what the width is of the web. This area right in here, this is what's doing all the work in shear strength. And we also need to know the height. Oops. The height, that goes down to the bottom. So from the top to the bottom of this beam. We find these two values, the width of the web and the height of the beam, back on this table right here. Now what I'm going to do is I'm going to go to this button here that says dimensions, and then I'm going to scroll down until I find my W12 by 14 beam. W18 14 by 12. Come on. W12. All right, there we are. Now we're in the W12s. W12 by 14. So here is the beam that I'm looking at. And where I'm going to be looking in is a couple of the columns right here. First of all, the thickness, and that is in inches. And that value is 0.2. So I'm just going to put 0.2 here so that we remember. You'll see that in a second when I get back to the picture. And then the overall depth is right here. And that is 11.91. So I'm going to write 11.91 on here. And I'll go back to the chart so you can, or to my calculation so you can see what I got. So the web is 0.2 wide and the overall height of the beam is 11.91. So I'm going to put in 11.91, and that is inches, and times the 0.200, and that also is inches, and I'm going to close that. This is going to cancel, those 2 inches are going to cancel out, and I'm going to end up just with pounds. So, calculator time. Let's see if I can do this so you can see it as I'm doing it. Well, we'll just have to go right here. Okay, I'm going to put in 0.6 times 50,000. 50, 1, 2, 3, times 11.91 times 0.2 equals. So my VN W12 by 14 is going to be equal to 71,460 pounds. So I'm going to just draw a box around that. So my VN for the W12 by 14 beam is greater than this number up here, which is 13,500. So this is the VN of the beam. Because this value right here is 71,460 pounds, and this value right here is 13,500 pounds, and it's quite a lot larger than the actual beam is. So we're in good shape there. So our beam selection is good for shear. Okay, next up, doing deflections.